This is lesson number 1 of the Science Foundations unit. Our key question for this lesson will be, how do you ask a scientific question and find a reliable answer? That picture is from Thanksgiving time around Lake Tahoe, if you were curious. So here are some of the key questions. You don't really need to write these down, but these may help you as you are writing the intro portion of your notes. Please make sure you are doing these Cornell style. If you have not yet learned Cornell style notes, please pause the video. Go watch the video on the main Canvas page on how to take Cornell style notes. You should have these in 4 sections. There should be a section on top. You should have a line from top to bottom with about 1/3 of the space on the left and 2/3 on the right. And then you should have a line across the bottom for your summary. But here are the questions we'll be discussing. What are the difference between hypothesis and theory? What are the different types of variable? What is reliability? And what is bias? And how do you eliminate it? So scientists answer questions using the scientific method. Basically, the scientific method is not anything fancy. It's just a series of steps that you go through to find the answer to a question that you have. So that's a good diagram right there. This might be a good thing to add to your notes, is to include these steps. Anything I should say that you put into your notes, you can use later on quizzes and tests, because our quizzes and tests are open note. So first, you need to observe a thing and ask a question. So you could say, water freezes at a lower temperature when there's ice mixed in, or you could say salt makes ice melt. You could say that a Sharpie stains my shirt more than a ballpoint pen. So these are all observations that you have, and then you ask a question about it. Once you have your question, you then can develop a hypothesis. Now, a hypothesis is the key to the entire process. So that is a very important point. You want to make sure that you know that going in, because hypothesis is one of the absolute most essential things about an experiment. And it's also one of the things I really want to make sure that you learn from this lesson. If you don't have a good hypothesis, you obviously cannot do a good experiment. So if you want to watch the scientific method in action, let's have Sheldon from The Big Bang Theory explain it to us.
Have you noticed that Howard can take any topic and use it to remind you that he went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station. I mean, on a good day, dinner was a bag full of meatloaf. But hey, you don't go there for the food, you go there for the view.
Fascinating. Let me see if I can duplicate the result. Howard, I've always thought the lemon was an underrated fruit. Care to weigh in?
Not really.
Oh, well.
You know, people say the Soyuz capsule is a lemon, but... Yeah. But hey, that baby got me to space and back.
All right. So that's the scientific method in action. Now let's get back to what a hypothesis is. So a hypothesis should do the following. Number 1, it should be written as an if-then statement. When I say if-then, the if and the then aren't touching each other. It should start with if. You should then come up with what your experiment will do, what specifically it will do. And then you're going to write the word then, and you're going to predict the outcome. Now, when you predict the outcome, it is a specific prediction. You have to say exactly what you think will happen or which side will win if you're comparing 2 different things. The example, as you can see it there, if I wash my shirt in the laundry, then the stain will come out. You might even be able to be more specific and say, then you will no longer see pen on the shirt. So your hypothesis needs to say what you will do and your guess of how it will end, as you can see. It needs to include measurable results. Measurable meaning you can tell who won or lost. Measurable results usually is something to do with numbers. It's something you can count, or it's something you can measure on a scale with a ruler or something like that. So usually with numbers. Measurable typically means with numbers. Now, you also need to be very specific on what you are testing. You can't just say something like, if I do the experiment, or if I try 3 different pens. You have to be very specific on what you're going to be testing, and that obviously goes with the if part. So these are some bad hypotheses. Please don't ever write a hypothesis like this. If I wash my shirt, I will see if the detergent works. So the reason why that's bad is that's not really a prediction. That's just a statement of fact. That's like saying, if I fall into a pool, I will become wet. We know that. So if you wash your shirt, of course you'll see if the detergent works. Now, the way you could fix that is you could say, if I wash my shirt, then the detergent will work. That would be a good hypothesis. The second one, if my shirt is stained, then it will need to be washed. So that one, there's no prediction. You're not predicting anything. You're saying, if my shirt is stained, I have to wash it. Well, that's just, again, a statement of fact. Now, again, you could fix that by saying, if my shirt is stained, then the wash will take out the stain, or the wash will fix the stain. And then lastly, if laundry detergent works, then the stain will come out. Laundry detergent working is not an experiment. You could fix that. You could say, if I place laundry detergent in the washing machine with my shirt, then the stain will come out. So anyway, these are all bad hypotheses. Don't write any like this. So as we finish up talking about hypotheses, let's go ahead, pause the video, and I want you to write on the right side a study question. And how you do a study question is write down a question you think I might ask you on the quiz coming up next week, or I might ask you on the test that's coming up in a little bit. So right now, pause the video and write down a study question to wrap up everything you've learned about the word or the term hypothesis. Okay, hopefully you have that. Now, once you have your hypothesis, you can start your experiment. An experiment needs to test one thing, and it needs to test one thing only. And it needs to collect measurable data, as we mentioned before. You need to work to eliminate all the other contributing factors. So for example, if you are measuring which type of shoe makes you run the fastest, you want to make sure that the shoe is the only cause of your results, and you want everything else to stay the same. So we have some words for those. And so these are 3 different types of variable. You may want to make a note of the types of variable and what they are. So in order to get rid of contributing factors, we use these things called controls, also known as control variables. Now, in your notes, I want you to put in there that control means keeping the things the same as they are normally. So if I'm testing running shoes, I want to keep everything else the same except the shoes. So what are the things you keep the same? The track should be the same. The weather conditions should be the same. The runner, as best you can, should be the same. You don't want a 75-year-old person with arthritis and a 19-year-old track athlete. That's not fair. So you need to keep everything else the same. So in your notes, again, you should have the word control means the same. Then you need to know what the cause is. In this case, it was the running shoe. We call the running shoe the independent variable. Now, what does it mean for independence? Well, what is Independence Day? What do we celebrate on Independence Day, 4th of July? Well, we celebrate our freedom from England. So I want you to think of this. The independent variable is free from those controls. So all those controls we put in place, we keep everything else locked down. But the independent variable is free, and therefore the independent variable is the cause of the results whenever we get the results. So that's very important also. The independent variable equals cause. So if control means the same, independent variable is the cause. And then finally, the outcome, the results, is the dependent variable because it depends on the experiment. So in this case, the race time, if we have running shoes, if we have 2 racers running, who wins, the winner is dependent upon the shoe. So the results are basically like saying a dependent variable. So we have a science teacher in the England, I believe he's in England, I don't know where, but I found him on YouTube and I think he has a good explanation of this. So we're gonna watch this now.
Firstly, let's say that this is a running track and we have our runner here and he's going to run 100 meters. But each time he runs it, he's going to wear a different type of shoe. So we've got runners, casual shoes, and boots. And this is the thing that's going to change each time he runs this 100 meters. And this is called our independent variable. That's the thing that we're going to change each time he runs this experiment. So let's put his runners on first. We start the timer, he runs his 100 meters. We stop the timer, and he got a time of 27.3 seconds. And this is the thing that we're measuring. The thing that we're measuring in the experiment is called our dependent variable. It depends on our independent variable. He got a time of 27.3 seconds with his runners. We reset him back to the start. We put his casual shoes on. We start the timer. He runs the 100 meters. And this time, he got a time of 30.2 seconds. So a little bit slower this time. We take him back to the start. We put his boots on. We start the timer. He runs the 100 meters. We stop the timer. And this time he got a time of 33.3 seconds, which was his slowest time. So we can say that he runs the fastest with his runners, followed by his casual shoes, and then he runs the slowest in his boots. But that's not everything to this experiment. There's a few other things that we need to consider. The first thing to consider is the weather. We need to make sure that the weather was kept the same each time he ran the 100 meters. If it was sunny when he was wearing his runners, but if it was raining when he wore the other shoes, that's not really a fair comparison because the weather could have had an impact on his ability to run. The clothing that he was wearing is also something that we need to consider. We need to make sure that he was wearing the same clothes every time he ran this 100 meters. If he was wearing running gear, wearing his runners, he had to be wearing running gear for the other ones as well. Otherwise, his clothing could have affected his time. Same with the surface. If he was running on concrete or wood or grass, we need to make sure that that was the same every time he ran this 100 meters so that any difference in time was mainly just due to the shoes that he was wearing. That's what we're trying to achieve, an accurate and fair comparison between the types of shoes. Because these are the things that we're trying to control in this experiment, we call them controlled variables. And that's it for today's lesson. I hope you learned something. Please like and subscribe if you want to see more of these videos, and I will see you next time.
So there's a little graph to show you. Feel free to write this down in your notes if you'd like. You can pause the video and copy this down. Put a box on the left, draw an arrow, box on the right, and then a box underneath. So we have the cause, which is your independent variable. You have the outcome or the result, that's your dependent. And then you have other factors, sometimes called confounding variables. And those are the things we try to eliminate. Those are the things we try to control. So if you want to pause the video and draw this, you can. And then when you have the video paused, go ahead and write down 1 or 2 study questions about everything about what I would ask about variables. So on a test, what do you think I might ask you about a variable, or what a variable is, or the types of variable? So pause the video, write your study question, and come back when you're ready. Now, in order to trust the results of our experiment, we need to increase something called reliability, which is basically how much we believe the results. There are many ways to increase reliability. So first of all, you need to conduct many tests. This is known as having a large sample size. The larger, the better. So I'll give you an example. If you were to get a pack of bubble gum and you take the bubble gum out, you chew the bubble gum 3 times, try to blow a bubble, and the bubble doesn't happen. It splits, you never get a bubble. And then you throw away the gum and say, that gum is bad at blowing bubbles. Obviously, that's not fair. The bubble gum, A, you didn't chew it enough, and B, you only gave it 1 chance. So it would be better in the bubble gum example to chew the bubble gum many times, blow many bubbles, maybe even time it, see how many bubbles you can chew, or I'm sorry, how many bubbles you can blow in 10 minutes. And that's a more fair comparison. Another example I often give this is If I go onto campus and I ask 2 students who the best teacher is, and they both say me, can I then go to the principal and say, I just won best teacher award or the most popular teacher award? Well, no, I only talked to 2 people. But if I talk to 300, I trust the results more. And if I win out of 300, we could trust that result. Next, the test is better if you separate it into 2 groups so you have something to compare it to. So the example for this one is, imagine if you have a plant. If you want to see if a plant will grow or not, you want to have one plant where you're taking care of it and everything's normal, and then the other plant you add whatever you want to add to it, and that way you have something to compare it to. So, well, the one group that is tested is called the experimental group. So if you're doing something different, if you're experimenting on it, it is part of the experimental group. Now, one group stays the same as it is normally, and they are called the control group. And there's one other little thing to add there. The group that is the control group, if they are human beings, not a plant or not an ant, let's say, they often are given a placebo. That's how you say that word, placebo. It's not placebo, placebo. And basically what that is it's a fake version of what you are testing, because you want to make the subjects think they're being tested. Now, why do you do that? Well, it's pretty common for a human being who thinks they're supposed to be getting better because they're getting a medicine to literally have their brain start to make them get better. So you give them a placebo, and here's what you do. You basically tell this group on the left or one group on the left and say, listen, you guys are going to get a medicine, and then you give them the medicine and you see if they get better. But then you give another group a pill and you tell them, hey, this is a medicine, but it's not. It's really just nothing. It's a sugar pill. And you wait and see if they get better also. And listen, if they both get better, then your drug didn't work, because you can get better just by taking a sugar pill. So placebo is basically a fake version to make the subjects think they're being tested. And I have something interesting to share. First of all, this is kind of a funny meme. The mice on the left are looking over at the other mice and saying, well, I guess we're the control group, meaning I guess we didn't get anything, or maybe they got a placebo. By the way, ask yourself right here, which group of mice probably got a placebo? The ones that are vibrating vigorously or the ones that are sitting still? And hopefully you know that the ones with the placebo would have been the ones that are sitting still. But interesting, look at this article, and I just clipped the headline for you. It's a little bit older, but placebo effect works even if patients know they're getting a fake pill. Meaning the placebo effect is so strong that people often get better from the placebo. They get better even though they're told it's fake, because they're like, oh, well, I'm getting a pill, I must get better. I just thought that was interesting. All right, and finally, we need to eliminate bias from our research. And what is that? That is basically the human impact on an experiment. Researchers need to not be rooting or in favor of or trying to get one result or another. If you go into an experiment and you have a favorite bubble gum, going back to the gum, and you do an experiment and you want that favorite bubble gum to win, you might be biased. And so you need to go in and you need to be honest. So the results must be honest and unchanged. And also you can make the study blind. And what that means is the scientist collects data without even knowing which of the groups he's collecting data from. So if I'm doing the bubblegum thing, you have the people who are blowing the bubbles write down how many bubbles they blew, but don't tell you which gum it was. They make it a mystery, like label it A, B, or C, and you don't know which one it is. So you can't like favor or help one of them. Also, you can have what's called a double blind study. That's even better. That's where neither the group that's doing the test, meaning the scientists, or the subjects, the ones that are being experimented on, neither one of them knows which one they're getting. So that's called a double blind study. Those are even better. Once you have all your data, you can draw conclusions and share your results. And then if other scientists can then repeat your experiment and they find the same exact thing, your findings become something called a theory. Now, what is a theory? A theory is done after many experiments have collected data, and it basically explains the results. So you say, here is why this thing is happening, whatever the thing is. So a theory differs from a hypothesis because you're no longer guessing. In a theory, you need lots of data to support what you're saying. A hypothesis is literally just a guess with no data. So that's the main difference between the two, and you should remember that. That's very important, the difference between a hypothesis and a theory. So in this lesson, you should have learned what we literally just talked about. What is the difference between a hypothesis and a theory? What are the different types of variable, and can you name them and what they do? What is reliability? And why is it important? And then what is bias? Why is it bad and how do you get rid of it? Now ask yourself right now, do you know the answers to these questions? If I asked you these on a test, on say the short answer portion of a test, would you be able to give me an answer? If your answer is no, then you need to go back and review your notes. If you never took notes on any of these things, you need to go back and add notes for these things to your notes. But if you can answer all four and you're confident you can, then what you could do is move on to the last part of your notes, which is review your notes, go over to the left side of your Cornell style notes, put in there the absolute most important things that you have to remember. These 4 review questions are a pretty good way to start, or a pretty good way to do it. And then what I want you to do is put your notes down. I want you to go do something else. Go have lunch, go talk to someone, watch a TV show or watch a YouTube video. And then I want you to do is I want you to come back. I want you to come back to the notes and I want you to write a summary. The summary goes on the bottom underneath that line you drew. If you cannot write a summary because you have forgotten everything, you need to go back and review your notes. However, if you can go back and write a summary, then you're all set. You've learned what you needed to learn and you're ready to go. So once you are done with your summary, you are done with your first note. I thank you very much for your attention.